July 20th, 1969. An estimated 600 million people watch Neil Armstrong step onto the surface of the moon, the most watched live broadcast in human history. The camera transmitting that image used a format called slow scan television. 10 frames per second, 320 lines. The broadcast that reached living rooms around the world was a real-time conversion of that signal. Lower resolution, more noise. The original was better by a margin that no one preserved. 3 ground stations recorded the raw signal onto magnetic tape. Those recordings were deposited in the United States National Archives in 1970. In 1984, they were transferred back to NASA's Goddard Space Flight Center. Stated purpose: permanent retention. Sometime after that, those tapes were degaussed, magnetically erased, reused. No decision was made to destroy them. How that happens, with the most watched footage in human history, is the subject of this file. The Westinghouse Aerospace Division built the television camera for the Apollo 11 lunar surface. Compact, low power. Designed to transmit a live signal 239,000 miles through space on the bandwidth available from the lunar surface. Standard broadcast television ran at 30 frames per second, 525 lines. The lunar transmission link could not carry a signal at those rates. The Westinghouse camera ran at 10 frames per second, 320 lines per frame. In its high-resolution mode, 5/8 of a frame per second, 1,280 lines. A slower picture, a much sharper one. The signal arrived at the ground stations in SSTV format. It could not go out on the broadcast network as received. Each station needed hardware to translate it into standard television. The process used an RCA optical scan converter. The SSTV image was displayed on a monitor at the station. A standard broadcast camera was pointed at that monitor. The output of that camera, a camera filming a screen, was the feed that went to the networks. According to the CSIRO Park's technical analysis of the mission, the conversion introduced losses, lower contrast, geometric distortion. Detail that the SSTV format had captured did not survive the process. 3 stations received the Apollo 11 lunar signal simultaneously: Honeysuckle Creek and the Park's Observatory, both in Australia, and Goldstone in California. For the opening minutes of the moonwalk, NASA alternated between Goldstone and Honeysuckle Creek. Then it switched to Parkes. Astronomer John Sarkissian's account of the mission records the Parkes signal as of such superior quality that NASA did not switch away. Parkes carried the broadcast for the full 2.5 hours. Earlier that day, a violent squall had struck the site. The telescope's support structure had been swaying in the wind as Aldrin activated the camera. The operators held the dish on target. Each station was recording not the converted broadcast feed, but the raw SSTV signal coming off the antenna before the scan converter processed it, onto 1-inch magnetic data tape. 3 stations, 3 independent recordings. The Parkes tapes held the clearest signal of all 3. Images at the resolution of the Westinghouse camera. 1,280 lines in the format the camera was built to transmit. What the scan converter had discarded. They held what the world had not watched. After the EVA, standard NASA procedure applied. The recordings made at each tracking station, the raw SSTV data recorded onto 1-inch magnetic tape, were packaged and shipped to Goddard Space Flight Center in Greenbelt, Maryland. Not a decision specific to Apollo 11. Post-mission telemetry data, tracking records, and experiment recordings all moved from the field stations to the central facility. The tapes followed the procedure. Honeysuckle Creek shipped its recordings. Parkes shipped its recordings. Goldstone shipped its recordings. 3 sets of tapes, 1 address. In 1970, those recordings were formally deposited in the United States National Archives. They were cataloged under a single accession number covering all Apollo 11 mission recordings, over 700 boxes of magnetic tape. The 3 sets of tapes from Honeysuckle Creek, Parks, and Goldstone were not logged as 3 independent captures from 3 independent stations. They entered the archive as one collection, one entry, one reference number. The redundancy that had existed at the moment of capture no longer existed in the record. Accession number 69, A, 4099. The tapes remained in the National Archives for 14 years. In 1984, they were removed from the National Archives and returned to Goddard Space Flight Center. The transfer was initiated by NASA. The stated purpose, documented in the CSIRO Parks account of the mission, was permanent retention. That phrase is in the record. The National Archives is a public institution with a formal preservation mandate. Goddard Space Flight Center is the facility that had processed the recordings in 1969 and sent them to the archive in 1970. The custody chain was now complete. The tapes were back at Goddard. The system had been designed with redundancy. 3 stations, each one independently recording the signal, so that if one failed, the others remained. That redundancy was a feature of the capture. It was not a feature of the custody. All 3 recordings had followed the same post-mission procedure to the same facility. All 3 had been cataloged under the same accession number. All 3 had been transferred back to Goddard under the same order. In the record, the 3 tapes were one collection, one address, one inventory, one fate. Goddard Space Flight Center maintained a large archive of magnetic tape recordings, telemetry data, satellite imagery, and experimental records accumulated across decades of missions. A standing program existed to manage that archive. Tapes no longer needed for active research were identified, degaussed, magnetically erased, and returned to the inventory for reuse on future missions. The practice saved money. It was standard across NASA's operational centers. The Apollo 11 recordings arrived at Goddard in 1984 and entered that inventory. The program did not evaluate recordings individually. It operated on collections, batches of tape identified as inactive and processed together. A reel of data tape carried a mission assignment and a status. If the mission's active research requirements had been met, the tape was eligible. Apollo 11's active research phase had ended in 1969. The mission was complete. By any operational measure the program would apply, the recordings had no outstanding research requirement. They had no flag indicating archival significance, no designation separating them from the rest of the inventory. They were magnetic tape in a large collection of magnetic tape. Sometime after 1984, the CSIRO Parks account of the mission and Richard Nafzger's 2009 confirmation both document the fact of the erasure. Neither identifies the precise date. The last confirmed entry in the custody record is the 1984 transfer to Goddard. What happened after that is documented by result, not by record. Nafzger confirmed that the Apollo 11 recordings were part of a batch of 200,000 magnetic tapes that NASA degaussed and returned to circulation to save money. 200,000 tapes. Richard Nafzger stated on the record in 2009 there was no evidence of intentional destruction. The erasure was not a decision made about the Apollo 11 recordings specifically. It was the result of a standing program that processed magnetic tape without regard for the historical significance of what that tape contained. No one reviewed the Apollo 11 SSTV recordings and chose to erase them. The program did not require that review. The recordings were in the inventory. The program reached the inventory. Not concealment, not sabotage. Institutional indifference to archival value, applied without exception. The tapes had been at Goddard since 1984. For the next 2 decades, no one appears to have searched for them. The Apollo 11 SSTV recordings were not in active use. The mission was long past. Accession number 69, A, 4099 existed in the archive record. The entry was intact. In the years before 2006, that changed. Researchers who understood what the SSTV system had captured and who knew the original signal was better than the broadcast began looking for the recordings. They were not where the record said they should be. Richard Nafzger was a Goddard Space Flight Center engineer who had worked with slow-scan television systems during the Apollo program. He was assigned to lead the GSFC-led investigation into the missing recordings. The investigation traced the custody record forward from the 1984 transfer. Accession number 69, A, 4099, the National Archives deposit, the return to Goddard. Each step was documented. The record was intact up to the point the tapes arrived at Goddard. After that, nothing. No transfer to another facility. No disposal order. No note of any kind in the record. The investigation searched the Goddard archive directly. The original accession, over 700 boxes of Apollo 11 mission recordings, had been received at Goddard in 1984. Those boxes should have been in the facility. The investigation could not locate them. It was not that the recordings had been moved to another archive, another institution, or an off-site facility that lacked documentation. The search reached those possibilities and found nothing. The trail ended where the tape reuse program operated. The recordings had not gone missing. They had been processed. In 2009, Richard Nafzger went on the record. The investigation had reached its conclusion. The Apollo 11 slow-scan television recordings had been degaussed and returned to circulation through NASA's standing tape reuse program. 200,000 tapes across the agency. The erasure had recovered reusable magnetic media. No individual had reviewed the Apollo 11 recordings and made a decision to destroy them. The program had reached the inventory. The inventory had contained the tapes. That was the end of the record. The search was over. When the investigation established that the original SSTV recordings were gone, what remained was the broadcast. The signal that had gone out through the scan converters at the tracking stations in July 1969, the NTSC feed that had reached the networks, the footage that an estimated 600 million people had watched. That footage had been preserved in broadcast archive copies. Lower resolution, more noise. The losses documented by the CSIRO Parks analysis were in it. But it existed. The original recordings did not. Richard Nafzger's investigation arranged for the broadcast footage to be restored. According to Richard Nafzger's 2009 account, the firm engaged was Lowry Digital, a company that specialized in the restoration of legacy film and video material. Lowry worked from the best available broadcast archive copies of the Apollo 11 moonwalk footage. The restoration applied digital processing, noise reduction, stabilization, contrast correction, frame by frame. The result was released in 2009. The best available version of the Apollo 11 moonwalk footage, processed from broadcast-quality source material. The restoration was constrained by its source. The broadcast copies held the NTSC signal, 30 frames per second, 525 lines. That was what the scan converter had produced in 1969. Digital processing could refine what was in that signal. It could not add what was not. The losses introduced by the optical scan conversion in 1969, lower contrast, geometric distortion, resolution reduced from the SSTV format, were not recoverable. Information removed at the point of conversion was not in the broadcast copies. It was not anywhere. The best available recording of the Apollo 11 moonwalk is a restoration of a broadcast copy of a scan-converted version of the original SSTV signal. It is better than what aired in 1969. It is not what the Westinghouse camera recorded. The 1,280-line images, the resolution the camera was built to transmit, the signal the Parks tapes held, do not exist in any archive. The restoration recovered what degradation had obscured. It could not recover what had been erased. The tape reuse program that erased the Apollo 11 recordings was not designed to target them. It was not designed to evaluate what it was erasing. Richard Nafzger's 2009 account placed the total at 200,000 tapes across NASA, processed through the same procedure: inactive, degaussed, returned to circulation. How many held something irreplaceable is not documented. The record does not say because the record was erased alongside the tapes. The institutional failure at the center of this case was not a decision. No official chose to destroy the Apollo 11 footage. No policy removed it from the archive. What happened was the absence of a decision, the failure to create any designation that would have separated a recording of the first lunar EVA from a reel of routine operational data. The program that processed the tapes was indifferent to their contents. That was its design. The question this file opened with, how that happens with the most watched footage in human history, has an answer that requires no conspiracy to explain. An institution accumulated more magnetic tape than it could meaningfully distinguish. It built a procedure to recover that tape. The procedure worked as intended. What this file documents is what that procedure cost.